Hello, in this video we are going to study about capacitive transducer. Here we are going to know about what is a capacitive transducer and its working principle and its circuit diagram, types, its application, advantages and disadvantages. Now coming to the topic, what is a capacitive transducer? A capacitive transducer is to measure the displacement, pressure, and other several physical quantities. These transducers are preferred. In this transducer, the capacitance between the plates is varied because of the distance between the plates, overlapping of the plates due to dielectric medium change, etc. Now, the capacitive transducer working principle. As per the structure, these are having mainly two parallel metal plates which are maintaining the distance between them. In between them, the dielectric medium can be filled. So the distance between the two metal plates and positions of the plates can be changed the capacitance. So the variable capacitance is principle of these transducers. The basic difference between normal capacitance and capacitive transducer, the capacitor plates are constant in normal capacitors. Wherein these transducer, the capacitor plates are movable condition. The capacitive transducer formula, as we all know that C is equal to epsilon 0 epsilon R into A divided by D, where C is the capacitance and epsilon 0 is permittivity of free space, and epsilon R indicates the relative permittivity, and A indicates area of the plates, and D indicates the distance between the plate. And when the area is increasing, the capacitor also increases, and the distance is decreased and the capacitance is decreased. That is, capacitance is directly proportional to the area of the plate and inversely proportional to distance between the plate. The capacitance value is dependent on the distance between the two plates of the variable capacitance and occupying area of the plates and permittivity of the free space or relative permittivity and dielectric material. These are the main four parameters that we can change the capacitance of the capacitors. That is, in this equation we have mainly four parameters. By changing each four parameters, we can change the capacitance. That are the distance between the plate, area of the plate, and permittivity of the free space and permittivity of dielectric material. Now, change in dielectric constant can be vary the capacitance of the transducer, and the area of the plate of the transducer also can vary the capacitance value. And another factor is distance between the plate. They can vary the transducer capacitance value. And this method is mostly used. In this method, the dielectric medium and area of the plates are kept constant. When the plates are moving in the distance is varied, and this results the changing of the capacitance of transducer. That is, the above circuit diagram, it indicates the equivalent diagram of capacitive transducer. The circuit diagram of the capacitive transducer, the difference between the variable capacitor and the normal capacitor is the capacitance of the variable capacitor is changed, and the capacitance of the fixed capacitor is fixed one. Here the plates are fixed, but in the case of either plates are movable or dielectric medium is changed, or the area of the plate can change. In the case of normal capacitor, the capacitance value is fixed and it cannot be changed. Now coming to the types of capacitive transducer. According to the structure of capacitive transducer, there are mainly of four types. First one is parallel plate capacitance with a rectangular plate, and second one cylindrical capacitor transducer, and third one is semicircular parallel plates, and fourth one is change in dielectric between parallel plates. And in the case of parallel plate capacitance, this is also called flat type capacitive transducer. In this type of transducer, one plate is fixed and another plate is movable. This results in the capacitance value of this transducer. By this variation, the distance between D or area A can be variable. In the case of in the case of parallel plate capacitor, the first plate is fixed and second plate is movable. When the length is changed, the capacitance is increased, that is distance is changed, the capacitance is changed, and the distance is decreased, the capacitance also decrease. If the area varies, the capacitance between C should be when the plates having the distance of x, then the capacitance bit equal to epsilon into A minus Wx divided by area, where W is the width of the plate and x is the distance which is moved. That is a width into distance is equal to change in area. That is, when we move the capacitor or increase the area, at that time the width is constant but the distance is changed, and that breadth is calculated as change in breadth is calculated as x, and the area is changed according with it, that is area is equal to minus W into x, where W is the width of the plate and x is the distance travelled. In that equation we can change our area and capacitance also change in this case. And in the case of cylindrical capacitor, there are two cylinders and the middle portion is filled with our dielectric constant. Considering the cylindrical length, then the capacitance of the cylindrical capacitance is changed according to the equation C is equal to 2 pi epsilon 0 epsilon r into L divided by log R2 divided by R1, where R2 and R1 are the diameters of two cylinders. Radius of two cylinders. In the case of semi-capacitive transducer, this type will be provide the highest capacitance value that two capacitive plates are overlapped each other. These are preferable when this circuit requires the maximum capacitance. In this capacitance, one plate is fixed and another plate is movable, that is in an angular motion, which is connected across a shaft. In this type, the capacitance transducer where area is equal to pi r square divided by 2 and the capacitance is equal to area divided by 2d. That is the area by capacitance is directly proportional to A by D. Then the equation between epsilon pi r square divided by 2d. When the fixed plate is changed, at that time the capacitance also change according to the area of the plate is increased. And in the case of change in dielectric medium between two parallel plates, when the dielectric medium varies between two parallel plates of the transducer, that also varies the capacitance of the transducer. Therefore, capacitance is equal to C is equal to epsilon 0 into E1 L1 W plus E2 L2 W divided by D, where L1 and L2 indicate the length of first and second plates, and the W indicate width of the plate, and D indicate distance between the plates. Here if we change the dielectric medium, there are two type dielectric constants, E1 and epsilon 0 and 1 and epsilon 2. And the advantages of capacitive transducers advantages are discussed below. These transducers offer high input impedance, so the loading effect value will be too low. As we all know that for decreasing the loading effect, and the input impedance should be high and output impedance should be low. And the frequency response of the transducer is extremely high. And these transducers are highly sensitive and they are consuming low power to operate. So these transducers are called low power consuming device, and high resolution can be possible by using this transducer. And coming to the disadvantages, these are the few disadvantages of capacitive transducer. It has high output impedance. Because of this high output impedance value, a complicated circuit is needed to measure the output, and the output circuit needs to be powerful to maintain the high output immune value. And these transducers exhibit a nonlinear behavior due to edge effect. And these are temperature dependent. The external temperature value can affect the transducer capacitance value. These are the main disadvantages of capacitive transducer. And coming to the application of the transducer, these transducers have wide range of application in determining the quantities like temperature, displacement, pressure, etc. The capacitive transducer applications are below. These transducers have application in the field of linear and angular displacement with the sensitivity factor. One of the best application of the transducer is to find the humidity level. As the humidity value changes, the capacitance value of this transducer is also changes. By this value, we can measure the change in humidity. The variable capacitance pressure transducer is applicable to find the pressure variation by using the variable capacitance. These are the main applications of capacitor transducer. Now, in this video, we covered the capacitive transducers are useful to converting one form of energy into another form of energy by taking the change in capacitive value. These are the passive transducer because this required external power to operate them. And with the help of this transducer, we can measure the pressure, temperature, and displacement, etc. And these are the main points of capacitive transducer. After that, we studied the advantages and disadvantages of capacitive transducers and applications of capacitive transducer. These are the main features of capacitive transducers. Thank you.